Hello, today we're going to be working with domain and range in graphs. Domain is the set of all possible x values or the input in a function. X can be less than or equal to a number, it can be greater than or equal to a number, or it can go from negative infinity to positive infinity. The description is look at where the graph touches left to right, and we'll practice that so it makes a little more sense. The range is the set of all possible y values or outputs in a function. Y can be less than or equal to a number, or it can be greater than or equal to a number, and it also could possibly be negative infinity to positive infinity. And again, we're just going to be looking at the graph. So it's a little, just a mind, kind of like a mind trigger. Domain goes left and right. Those are your x values. And then your y values go up and down or vertical. That's your range. Just a quick review. Open dot means the point is not included. And that's typically used with less than or greater than. A closed dot, the point is included. And so we typically see that with less than or equal to or greater than or equal to. And if there are no dots, that means the graph is continuing to go on. Should have arrows, or it will be going off the graph itself in most cases. So we're going to look at this. It says domain is all the possible x values of a function. So I see I have a point here, so it ends here. And I have a point here, and it ends here. So what I'm going to do is I'm going to look to see on my x-axis where these points line up. And x can be any points between these two. Okay? It's a solid point, so it's going to be x is less than or equal to this number, or it's going to be greater than or equal to this number. I'll just do an and symbol. Okay? The range is all possible y values in a function. Again, I look at the highest point that my graph is showing me and my lowest point. And then I'm going to go over to the y-axis to find out what my highest number for x is going to be, or sorry, for y is going to be, and then again here. So in this case, I'm going to have y is a closed circle, so y is going to be less than or equal to this number, but it's also going to be greater than or equal to this number here. Okay? So two different numbers here. Okay? Let's practice. We're going to look at each of these graphs, and we're going to determine what the domain and range of each function is based on the graph itself. So let's take a look at the first one. So I have this V shape. It looks like the lines are going off the grid, so it is continuing on. And in cases like this, this means that this is going to go to negative infinity, and this is going to positive infinity. I also notice it comes to a sharp point at this point right here, and this is going to be my my lowest y point that I can possibly get. So my domain, that's my x values, they're going on and on and on, and they can just go on for forever. So it is going to be negative infinity. Let's see, it's greater than or equal to x, which is greater than or equal to positive infinity. My range, I see that this is the bottommost it goes, and it looks like it's going up to positive infinity. It's just going to continue to keep going up. It spreads out, but it's going up as well. So that means that x is going to be, that y is going to be greater than or equal to negative 4. And this is telling me that the lowest point is negative 4, and it can go all the way up to positive infinity. I don't have to write all that. Let's take a look at the second one. This one, they did give us arrows. on both ends. And so my domain, if I have arrows, they're going to continue to keep going on and on and on, right? So it's going to go negative infinity, x is greater than or equal to, or less than or equal to positive infinity. My range, that's my y values. Again, I don't see a minimum and I don't see a maximum, so it's also going to go from negative infinity to positive infinity. So negative infinity less than or equal to y is less than or equal to positive infinity. Let's take a look at the third one. The third one, I noticed a couple of things. One, it has a minimum value here, and it has an open circle here. And remember, the open circle is when it cannot be that point. And so the open circle means it can be greater than or it can be less than. And since it is going this direction, that means that x is going to be less than this point. And this point is at 2. So x is going to be less than 2. I don't have to say that it's going to be greater than infinity, because it's just implied that if it's less than 2, it's going to continue to keep going down to negative infinity. We just don't know what the last number in negative numbers is. Okay, let's take a look at the range. Again, I see that my lowest point is here. And even though this one is stopping, this one is continuing to rise, isn't it? So this is telling me that y is going to be greater than or equal to 1. So y is going to be greater than or equal to 1. Even though this has an endpoint, this one does not. And that's why we use greater than or equal to 1. And here's our fourth one. I have an endpoint right here. And I have it's going off the graph. So I have infinity there. So when I look at this, my least number that x could possibly be is 0, isn't it? It is a solid point because it wasn't a hollow point, and it's going on to infinity because it's going to continue to keep going. So my x is going to be greater than or equal to 0. Then when I look at my y, this point is the lowest point it is, isn't it? So, but then it keeps going higher, and it'll keep going, keep going, keep going, keep going. We just don't know how high it's going to actually get because it's still rising as it's exiting the graph. So we know that it's going to be y is greater than or equal to 0 as well, because 0 is my lowest point. And because it was closed, it's telling me that it's or equal to. All right, let's practice a couple. This one's an odd one. It's not like the others. It has a hump in the middle of it, but I can take some information from it. Well, this is my least points, right? And they're even. And so as I come across, and then I notice I have these arrows. Okay. I also notice that while it's going up, it's also not spreading out as much. So it's probably not going to get very wide. Eventually it'll start narrowing out, but we just don't know for sure, do we? So what I can take from this is that it's a possibility it'll keep spreading further out as it goes. So we're going to say that it is greater than negative infinity, and it is less than or equal to positive infinity. My y or my range, the lowest point that's showing is what? It's -2. Yeah, that's -2. So because it's a definite end, where those are like solid points, and it's at -2, so y is going to be greater than or equal to 2. It could be greater than or equal to -2. Here's a question for you. When you are determining the range of a function, which coordinate, x or y, of the relative minimum and maximum do you use when we're looking at the range? Remember, is range your x values or is range your y values? If you said your y values, you are correct. So it is your y values. When you're determining the domain of a function, which coordinate of the relative minimum or maximum should you use? Well, if the range is my y's, my domain would be my x values. Okay? If you have any questions, please make sure you speak with your teacher. Thank you.